In this question, it is given that the angular bisector of angle A in the triangle A, B, C with coordinates given having the equation ax plus 2y plus c equal to 0, then the value of A and C are. The meaning of the question is a triangle ABC is given with coordinates as minus 8, 5, minus 15, minus 19 and 1, minus 7. And angular bisector of angle A has the equation ax plus 2y plus c equal to 0, and you have to find the value of A and C. To get the value of A and C, we require two relations in A and C, and from those relations you can get the value of A and C. First relation we can find by putting the point minus 8, 5 in this line, that is I get minus 8a plus 10 plus c equal to 0. This is one relation between A and C. To find another relation between A and C, we find the coordinate of this point, that is D, which is the point of intersection of angular bisector and BC. We know this property that BD upon DC is equal to AB upon AC. That is BD upon is equal to, we can easily find the value of AB as under root 49 plus 24 square upon under root 81 plus 12 square, that is equal to under root 49 plus 576 upon under root 81 plus 144, that is I get 25 is to 15, that is which is equal to 5 is to 3. And using section formula you can get the coordinate of the point D as five into 1 plus 3 into minus 15 upon 5 plus 3, and then 5 into minus 7 plus 3 into minus 19 upon 5 plus 3, that is equal to minus 40 by 8 and minus 92 by 8, that is equal to minus 5, minus 23 by 2. Clearly this point lies on AD, hence it will satisfy the equation AX plus 2y plus C. Putting this point in the line AX plus 2y plus C equal to 0, I get minus 5a minus 23 plus C equal to 0. One relation we have already got, and that is minus 8a plus 10 plus C equal to 0. And to find the value of A and C, clearly subtracting I get 3a minus 33 equal to 0, that is A equal to 11, and afterwards C becomes 78. Hence I can say A becomes the correct choice. In this question it is given that, in this question he is asking that the reflection of the curve xy equal to 1 in the line y equal to 2x is given by this equation. Then the value of R is. It is written as 12x square plus rxy plus sy square plus t equal to 0. You must be knowing that suppose you have to find the equation of some curve. The procedure is always, suppose P having coordinate hk is some point on the curve, and to find the equation of curve means find such a relation in h and k which is not containing any other variable except h and k. Once that relation is found which is not containing any other variable except h and k, after that we write x for h and y for k. H is replaced by x, k is replaced by y, and you get the equation of curve. The same is the procedure when you have to find the locus of a point. And here x, y equal to 1 is some curve, and y equal to x is some line, and you have to find the equation of image curve. This can be written as 2x minus y equal to 0. Let hk be any point on the curve. Your main aim is to find the relation in h and k which is not containing any other variable except h and k. If this is the point hk, this point which is mirror image of hk in this line, this point can easily be found in terms of h and k. Say this point is suppose alpha beta. What I am going to do is I will find alpha beta in terms of hk. After that, using the condition that because alpha beta lies on it, alpha beta equal to 1. Once alpha and beta both are found in terms of h and k, putting those values of alpha beta in terms of hk here, you will get a relation in hk, and after that we will be replacing h by x and k by y. See what I am going to do. Because I want alpha beta in terms of hk, using the formula of finding the reflection of a point in a line which is suppose ax plus, and this is the point x1 y1, this is the point x2 y2. We can easily get the value of x2 y2 in terms of x1 y1 using the formula x2 minus x1 upon a, y2 minus y1 upon b, minus 2 into a x1 plus b y1 plus c upon a square plus b square. If you equate these two, you will get the value of x2 in terms of x1 y1. If you equate these two, you will get the value of y2 in terms of x1 y1. And keeping this formula in mind, as I want alpha beta in terms of hk, I will be writing alpha minus h by 2, beta minus k by minus 1 equal to minus 2 into 2h minus k by 2 square plus minus 1 square. That is alpha minus h is equal to minus 4 into 5, and beta minus k is equal to 2 into by 5. That is alpha is equal to minus 3h plus 4k by 5 and beta equal to 4h plus 3k by 5. And because alpha beta lies on this curve, hence I get the conclusion that alpha beta is equal to 1. That is, I can say minus 3h plus 4k by 5 into 4h plus 3k by 5 equal to 1. That is minus 12h square plus 12k square plus 7hk minus 25 equal to 0, which means 12h square minus 12k square minus 7hk plus 25 equal to 0. And now comparing this and this given equation where r is the coefficient of xy, we can easily say the value of r is minus 7, because in the last we are going to write x for h and y for k. In this question, he is asking that passing to the point 75, then the point of incidence is. That is, the meaning of question is, suppose this is x-axis and this is the point minus 1 1. A ray of light starts from here and gets reflected, and then after reflection passes to the point 75. You have to find the coordinate of point of incidence. As we know the property of light, that the reflected light behaves like it has come from the mirror image of this point in this line. That is, the mirror image in x-axis will be minus 1 minus 1, and the reflected light will behave like it has come from the point minus 1 minus 1. And we have to find the x coordinate of the point P. Say this is A, this is B, this is C, D. One way of doing this question is, two points are known to you, you can get the equation of this line and then check where this line is cutting x-axis. Agreed, it is not wrong, but I will say better is the perpendicular. It is clear that these two triangles are similar, hence this length is to this length. Suppose this point is E. It is clear that the length dp is to pe will be equal to dc is to be, because the two triangles are similar, and this length is clearly 1, this length is 5, and suppose this point has x coordinate alpha, clearly means the point P divides the line joining D and E internally in the ratio 1:5. Therefore alpha is equal to, clearly the x coordinate of this is 7, the x coordinate of this is minus 1. So 1 into 7 plus 5 into minus 1 upon 1 plus 5 is the value of alpha. That is, alpha is equal to 2/6, that is 1/3.